I'm going to draw the line structure for Darvon. Double bond. And that is the molecular structure of my drug, Darvon. Continuing with the rest of my molecular portfolio, I would like to introduce you to my drug. The brand name is Darvon, and the generic name is proproxifen. Chemical name is, of course, long, but it's 4-dimethylamino -3-methyl-1,2-diphenylbutan -2-YL propanoate. Hope that made sense. So the drug is used as an analgesic or a pain relieving drug that is used to treat mild to moderate pain. Darvon is considered a narcotic and considered addictive as well. You should not take the drug Darvon if you're a patient with conditions such as suicidal thoughts, alcoholism, alcohol intoxication, drug abuse, depression, just to name a few. With the list of health contraindications being so long, it is truly imperative that one considering taking Darvon consult with their doctor and disclose full medical history. Significant interactions with other drugs would include Darvon contains a CNS, which is a central nervous system depressant, which is an additive to other CNS depressants, including but not limited to alcohol, which explains why patients who experience alcoholism and alcohol intoxication should not ingest Darvon. Darvon has the ability to enhance the effect of anticoagulants and may slow the metabolism of other drugs taken at the same time. The effect of slowed metabolism was observed when Darvon was taken in conjunction with antidepressants, anticonvulsants, and warfarin-like drugs. Something interesting about the drug is that Darvon is no longer being prescribed. On November 19th of 2010, the FDA announced that Darvon would no longer be on the market in the United States, along with its counterpart, Darvocet. It was revealed through scientific evidence that Darvon can damage the heart and can even cause fatal abnormalities, despite following recommended dosing. This is an example of my pre-drawn line bond skeletal structure in lone pairs. And here we have the expanded structural formula where I have placed in the hydrogens with each carbon bond. And my Vesper theory molecular geometry predictions, where I have my key down here, and it shows tetrahedral bonds, trigonoplanar bonds, bent bonds, as well as trigonopyramidal. Here I show you how I came to the conclusion of my molar mass calculations for the drug Darvon. And I show my knowledge of hydrogen bonding with water here in this example. I did 2 bonds here because there was more than one set of lone pairs. I also did it here, and with the fluorine, I did bonds on all lone pairs. And as for my drug, I show the main portion of the molecular structure. I outlined it in black. I show the hydrogen bonds in red, and I left the water molecules in just pencil to differentiate. So we see here. And here is polarity and solubility predictions for the drug Darvon. There's polar bonds here, here, and here. And I predicted that Darvon will be soluble in water because it has many hydrogen bonds and contains polar bonds as well. And I was correct. It is soluble in water, 3.32 milligrams per liter at 25 degrees Celsius per Chem. And here I have the calculations for making a solution with my drug. And last but not least, I have the summary of collaboration for shared effort. And I would like to say that I did most of the work. I got the app for the video. I did the drawings and the calculations. I also turned this in. Me didn't do much. And myself, I give credit to myself for research and watching all the videos needed to complete the molecular portfolio. I hope you enjoy the video.